Hello, 8th grade. We are going to do lesson AM1, unit AM1, lesson 19, rearranging formulas. This was a special request by a student in the class. So I will go over what we learned yesterday in class. Let's cut right to it. Again, what I want you to do though is I want you to go to S.103. Lesson 19. It may be a different page if you have a different year, different edition, but you want lesson 19. We're going to be doing some problems straight out of there. Your book will, your binder will help you out. So let's cut straight over to our pad, and let's look. And so you'll see this is exercise, 1 up there at the top. We solve. This is A, B, and C. And the whole idea here is rearranging formulas. And what we're going to do here is we're going to connect, not correct, call it connect, our prior learning. And we're going to connect, I'll call it prior learning, and we're going to connect solving equations to rearranging formulas. And we'll see that it's the same thing. It's the same thing. And the whole idea, this is a light bulb. Well, light bulb. The whole idea is that, what you do to one side, you do to both sides. And the other kind of idea, that's idea number 1, and the other idea 2 is you want to isolate the identified variable. So those are your 2 ideas. All right, so let's look at how we do this. So let's cut back to our blue pen. And how do we solve a problem like this? Well, step number 1 is we're going to add 6 to both sides. We add 6. So we get 2x equals 16. And step number 2 here is we div 2. So we div 2 and we get x equals 8. And then we can go about checking, but we're not going to do this. Today. So let's look here at B. Now it might look like a different problem. It's got negatives and everything in it, but let's see what we do to solve. We add 3. Negative 3x equals negative 9. So we, again, we add, and then we divide. Same thing. You're going to add the same thing to both sides, and then you're going to divide both sides by the same thing, right? We add, then we divide. Okay. So here on C, the whole idea, and we could solve for any other variable, but right here we solve for x. Here we solve for x. Here we're going to do what they call solve for x. Okay. So the whole idea is to say that we want x equals what? Well, we're not going to get an exact numeric answer. Here we got, numeric answers. Here we're going to get something different, but we're going to do it the same way. We're going to add something to both sides. We're going to isolate this x. We want the x by itself. So what we're going to do is we're going to add b to both sides. And that gets us one step closer to having x by itself. Remember, over here, we're trying to get x by itself, because we want to know x equals 8. Get all these numbers kind of over here to the right. Over here, we want all these letters over here to the right, all these variables, unknown values. Now we add. We start by adding, and the next thing we're going to do is divide. Step 1, step 2. We divide by A. So now we get x equals b plus c over a. And there's our formula. You could have also ended up with x equals b over a plus c over a using properties that we know about how to separate numerators and denominators when the numerator has an addition sign in it. So either one of these is fine, and so there we go. We got our the first idea, happy cat. First idea is that we can work with variables just like we can work with numbers. As long as we're doing the same thing on both sides, we can isolate any variable, okay? And we use this idea of what we do to one side, we do to both sides. If we're adding A or adding B or dividing by A, we did it to both sides. And we isolated the key variable that we were searching for. Okay. New page. So let's go all the way down to exercise 4 and 5. We're not going to do everything. Exercise 4 and 5. And that's going to be, so we're going to do 4A. So let's start with 4A. And 4A says we have a formula, P equals 2 times length plus width. And this is, for those of you who want to know what this formula is, right? This is the perimeter of a rectangle, right? So the perimeter of a rectangle, perimeter equals, the length plus the width times 2, right? So if this was 10 and this was 5, our perimeter would be 2 times 15 or 30. 2 times, whatever equals 30. And you can see that because this length would be 10 and this length would be 5. So you'd have 5, 10, 5, 10, 30. Okay, enough of that. But the point here is we want to solve this equation for a certain variable. And so in this case, we're going to solve it for L. Now, because that's what the problem asks us. We want to solve for L. So we want to isolate this L. So we need to undo our operations that have been done to L or have been done to this side to kind of move these variables and constants to the left side. So the first thing we're going to do is we can do two things. We can either, as we know, we can either distribute first or we can divide by 2 first. So let's try dividing by 2 first. Either one will give you the same answer. So now we have P over 2 equals L plus W. And now we're one step closer to solving for L. So I'd like you to think about what we can do to get rid of this W, and the answer is subtract W from both sides. Right? So we've divided both sides by 2. We're subtracting W from both sides. And then we get L equals that. Let's use our reflexive property and say, well, L is equal to P over 2 minus W. And so now we've solved for L. Now I'll leave it to you to solve for W if you'd like to do that exercise. But the problem now says, hey, let's use this original equation or let's use our new equation, to solve for L. So that we've already done. This was kind of part 1. Now part 2 says solve for L when P equals 70 and W equals 15. So let's go about doing that. So let's use this original equation and then we'll use our new equation. So let's just go to a different color. Let's write our original equation down. And then let's write our new equation. And let's see if we get the same answer for L when we solve both ways. So we're going to use this and this. So let's plug in our 70 for P and our 15 for W. And over here, we're going to do the same thing. and see if we come up with the same answer. So over here, let's divide by, well, let's distribute first. Let's do that. You can do it either way, but let's just see what happens. This will be fun, right? We distribute. Now we're going to subtract 30 from both sides. And now we're going to divide both sides by 2. 20 equals L. Now, so we started with this formula and we got to here. Now let's see what happens when we do this formula. L equals 70 over 2, 35, minus 15. L equals 20. And so we get the same answer. Wow, that's really cool. Happy cat. So the whole idea of exercise 4 and 5 says, hey, when we rearrange formulas, we still have equivalent formulas. They're just written in a different form. This form up here solves for P, this form here solves for L, but they are equivalent and can be used to solve the rest of the for the rest of the variables if we know all the rest except for one. Now I'm going to let you do this one. A equals a half of BH. And we want to do 3 things again. We want to solve for, okay, so here we want to solve for B. And then we want to use the original equation to find B when A equals 100 and H equals 20. And then we want to use our new formula to do the same. All right, so let's go through this and let's find, let's see. So we're going to solve for, we want to solve for B. So we want to get our numbers and our variables to the other side. So the first obvious thing to do is let's multiply both sides by 2. So now we get 2A, and this 2 will cancel this half. So 2A equals BH. Now, to get to B, we need to just divide both sides by H, and we're there. 2A over H equals B, or B, using our reflexive property, equals 2A over H. So that's part 1. Now let's use our original equation to find B when A is this and H is 20. So let's plug in our numbers. 100. Again, we're using our original formula of A equals 1/2 of B times H equals 1/2 of B times 20. Well, let's use our commutative property here of multiplication. And so we get 100 equals 1/2 of 20 is 10 times B, divide by 10, and we get 10 equals B. Now let's use our new formula and see if we get the same thing. So our new formula says that B equals 2A over H equals 2 times 100 over 20 equals 200 over 20 equals 10. So B equals 10. So again, we get the same thing. Well done. Happy cat. New page. Okay, so hopefully these are getting a little bit easier. Now I want to do one more sample, and I want to show you there's a trick. Sometimes you're going to see things like this. AX plus BX equals C. And it will say solve. Now this is key. This is key. This is hard. This is getting harder. So if you've been flipping through, don't miss this. Don't miss this. Okay? Solve for X. Now the whole idea, the key, the key, is if you have 2 of the variable you are solving for, get it to 1 variable. That means sometimes you have to combine terms or undistribution, which is also known as factoring. These are going to be your 2 keys to do this. Well, here we see that if I say solve for x, so I'm going to go to a different pen color. If we have to solve for x, we can't solve for x because let's say I tried to solve for this x, and I'd say, well, ax equals c minus bx, and then divide both sides by a, and I'd get x equals c minus bx over a. Well, I've solved for this x, but I kind of have this x hanging out over here. And the whole idea is you need to get all the x's. You need to get the 1 x on the left. You need 1 x on left and none on the right. We're going to erase all this. We go backwards. Erase all of that, and we're going to have to do something different. So the key here is, how do we create 1 x? How can we rewrite this with only 1 x? Well, the idea is to factor. So we are going to pull out, as they say, an x, or undistribute, and we get this. And now we neatly we've turned 1 x, 2 x's, into 1 x. So now we can conveniently just divide both sides by a plus b. That cancels, and we get x equals c over a plus b. Okay, so let's do, a happy cat. Let's do one more. Whoa, not one more happy cat. We got to solve something to get a happy cat. So let's just do one more, and let's look at this one. We see ax equals 2bx plus 9c. Let's just say 9c. Let's make this a little more difficult. Now I want you to think about how you can get all your x's onto one side and then factor them. You can pause the video, think about this, and the whole idea is you're gonna want to get this guy over there. All right. Well, let's go. Hopefully you thought about it. So we're going to go ax, and we're subtracting 2bx from both sides. So we get ax minus 2bx equals 9c. Now we're going to factor that x. And so we get x times a minus 2b equals 9c. And now we're golden. We just have this x. So if we divide both sides by a minus 2b, we get x. This will cancel. X equals 9c over a minus 2b. And we can definitely earn another happy cat for that. And let's move on to one more example. Let's do the one out of the book on S.106. Let's do this one here. Again, so this is example 2. It's on S dot 106, you know, less than 19, still less than 19. It's on S dot 106 in my book. And it is solve AX plus B equals D minus CX. Solve for X. I want you to pause and try. Okay, pause the video and try, then we'll come back and we'll see what we got. Okay, so I'm assuming you're back. So the whole idea is we're going to solve for X. So if we're going to factor that guy, we need to get all the X's onto the same side. So we get AX plus CX plus B equals D. Well, I need to get this B over to the right, so let's do that, because that's not part of our factoring. So let's AX plus CX equals D minus B. Now we factor. X times A plus C equals D minus B. And I divide both sides by A plus C. We can put those in parentheses just so we can really see it. Cancel, and we get X equals D minus B over A plus C. Happy cat. Good work. We can let's do one more. I'm going to do one more equation, and this one has to. It's kind of like these ones, but let's look at this is example. This is actually problem set number 7. In the problem set number 7, I'll give you this one for free if you're good enough to watch this, and let's just see how we deal with this situation. And this says solve for X. And I'm going to give you a hint. My hint is to get rid of all fractions first. And think multiply. Okay, so pause and think. Okay, so I'll assume that you've paused the video and you've thought about it, and if you haven't, do it now, and now come back. So if I want to get rid of all these fractions, I can multiply everything by m in p. See, if I multiply everything by m, I'm still going to have a fraction here, and I'm still going to have a fraction here. But if I multiply everything by m in p, I will have gotten rid of all my fractions. So let's look at the right side. If I multiply 1 over p times m in p, my p's will cancel, and I get m in. If I multiply x over m times m in p, I get n p x, right? My m's will cancel, and I'll get n p x. Similarly, if I multiply m in p times x over n, my n's will cancel, and I'll get m p x. Right? So I can now do what? I now have a problem that's like the one we did on the last page. So I'm just going to factor. And I can factor out an x, and I get np, dyslexic, np minus mp equals mn. And if I want to make sure that I get that, I can redistribute back, and I can say, well, x times np is npx, and x times mp is mpx. So this is correct. I've correctly factored this. And now I'm going to divide everything by this value here. And I get x equals mn over np minus MP. And so this was good. You know, this is good. If you got this happy cat, you've learned the lesson. You did not, you didn't get Ray Gun Man. This would be like, get the happy cat. Well, no, you don't get to do that, because the happy cat is the victor, because we got our answer right. We get happy cat. Happy cat destroys big scary man. Happy cat. Grrr. Okay. Anyway, that's it. We are going to call that a wrap. We're back, and hopefully this was helpful for you. Lesson 19, quiz on lesson 14 through 19 coming up. Have a great day.